All right, so in today's video, we're going to talk about density. Density is a property of matter that describes the amount of matter per unit volume area. Basically, how much stuff do you have in a given amount of space? One way you can describe density is how compact something is, but it is a very, very useful property that allows you to identify an unknown material. So our formula for density is density equals mass over volume. So that means when calculating it, you're going to have some unit of mass. So we're going to have grams most often, but you can also see it in kilograms or milligrams, are two of the more common variations of this. And then for volume, it depends whether you're dealing with a solid or a liquid. So for liquids, we're going to see things in liters or milliliters. If we're dealing in solids, we're going to see things in centimeters cubed, meters cubed, and sometimes also decimeters cubed. Those are all pretty common units of volume for a solid object. So when we write out the equation for density, we are going to use abbreviations. So density, D, equals mass, M, over volume, V. And that allows me to calculate density. But if I was given density and given volume and asked to calculate mass, I could also do that by simply rearranging this three-variable equation. So if I want to solve for mass, I can take the volume, I can multiply it across. That's going to give me VD equals M, and now I can solve for mass. I can also do the same thing if I want to solve for volume. So if I want to isolate volume, I want to move everything else away from it, I'm going to take my density, I'm going to divide it across, and that's going to give me volume equals mass over density. So one very easy to manipulate equation is going to allow me to calculate three different variables. The density equation is one of the equations that's located on your reference packet. It's in fact the first one on the formula sheet. Easy to identify, not one that you generally have to look up because you're pretty familiar with it, I think, by this point. So we're going to work through 4 problems in this video. I'm going to show you one example of solving for density, one for mass, one for volume, and then we're going to look at a 4th problem that kind of leaves some information out that you have to go and find to be able to solve the problem. So let's look at the first one. Determine the density of an unknown metal whose mass is 783.5 grams and occupies a space of 53.6 milliliters. So I'm solving for density. I'm given mass in grams. I'm given volume in milliliters. Even though it doesn't say that this is volume, I recognize milliliters as one of my volume units we discussed up top. And so I know that this is going to take the place of that V variable when I plug in. So I'm going to start by writing my equation. Density equals mass over volume. Because I'm solving for density, I'm going to keep it in its traditional form. I'm going to plug in my numerical values that I was given. So my mass is 783.5 grams. My volume is 53.6 milliliters. So go to my calculator. 783.5 divided by 53.6 gives me 14.6175, 3 and change. Okay. But what have I not done? I haven't considered my significant figures. These are both measured values. Remember that in significant figures, I cannot have an answer that is more precise than my least precise measurement. So I'm doing multiplication and division here. I need to consider my total number of Sig Figs. So 783.5 has 4 Sig Figs. 53.6 has 3 Sig Figs. Therefore, my answer is going to be able to have 3 Sig Figs. So 1, 4, 6. The 1 is not going to round, so I just drop it off. So my answer is going to be 14.6. And then I need to look at my units. The grams and the milliliters do not cancel out. They're actually going to just write together grams per milliliter. And that is a density unit with a mass and a volume, so that should make sense. So my answer would be 14.6 grams per milliliter. All right. For my next one, what is the mass, so we're solving for m this time, of an object that has a volume of 12.5 centimeters cubed and a density of 6.75 grams per centimeter cubed. So now I have a density here. So this time I'm asking myself to solve for mass. So I'm not going to use the density as mass over volume. I'm going to have to use one of my two rearranged formulas. So I'm going to be using the one that allows me to solve for mass, which is VD equals M. And again, you don't have to memorize these. You just have to know how to manipulate this one to be able to arrive at this formula down here. So VD equals M. I'm going to plug in my volume, which was 12.5 centimeters cubed, my density, which is 6.75 grams per centimeter cubed. All right, go to my calculator. So 12.5 times 6.75 gives me 84.375. All right. Considering my Sig Figs, 1, 2, 3, 1, 2, 3. So I'm looking at 3, 1, 2, 3. And in this case, the 7 does round this over, so it's going to be 84.4. Now let's talk about our units. So 84.4, and I've got grams, and I've got grams per centimeter cubed. So the centimeters cubed are going to cancel out because this is really centimeters cubed over 1, and this is grams over centimeters cubed. So top of the fraction, bottom of the fraction, they're going to cancel out. It's going to leave me in grams, which, considering I'm being asked to solve for mass, should make good sense. I need to have only a mass unit left, and that is indeed what I have. Okay. All right, so for our last of our 3 different types, the next one says, what is the volume of an object that has a mass? So what is the volume? I'm solving for volume that has a mass of 15.40 grams and a density of 715 grams per centimeter cubed. I could not read for a second there. So this time I'm being asked to solve for volume. So volume is mass over density is going to be my formula. So I'm going to plug in my mass on the top there, 15.40 grams over my density of 715 grams per centimeter cubed. And when I go to my trusty calculator, 15.40 divided by 715 is going to give me 0.021538. All right, so let's check our Sig Figs. 1, 2, 3, 4. Remember that 0 does count because it's following a significant digit, following a decimal. So this is 4 significant figures, and 715 is 3. So my answer is going to have 3. Now remember here, this is a leading 0. It does not count. If I were to put this number into scientific notation, that 0 would not be there. So I'm going to start counting significant digits at the 2. So 1, 2, 3. The 3 does not round the 5, so I'm going to lock that end part off. 0.0215 is going to be my answer. And then when I look at my units, my grams and my grams are going to cancel, and it's going to leave me in centimeters cubed, which is a volume unit. All right. So let's look at our last one. So our last one is no more challenging than the first 3, but it just seems like something is missing. In examples 1, 2, and 3, you were given 2 numerical values in the problem. Well, as you see in question 4 here, I've only given you 1 numerical value. What is the volume of the copper that masses out at 17.36 grams? Well, I know I can use the density formula to find volume, provided that I have both mass and density, but density is not given. What is given in the problem is the identity of the substance. Well, how does that help me? Well, That's where ye old reference packet comes in. So on your reference packet, you have a chart. If you have the printed out version, it is at the bottom of the first page. And notice here you've got a list of metals, and then you've got some information about them: specific heat, which we'll use later, density, and melting point. So in particular, we are looking at copper. And copper, if I zoom in here, you can see, there it is, has a density of 8.92, and then our units are grams per centimeters cubed. So I now know what my density is. Well, if I have density and mass, I can find volume. So I'm going to write down my known value of the density of copper, 8.92 grams per centimeter cubed. Now, let's talk about this number for a second. Oh, I should zoom back out. So this is what we call a constant. It is coming from a reference material. Because it is coming from a reference material, even though I'm writing it down as only these 3 digits, you can actually say that it goes out to an infinite number of zeros behind that too, or you can at least conceptually think about it that way. We know that the density of a pure sample of copper is exactly 8.92 grams per centimeter cubed. Exactly, right? We can say that with a great deal of precision. So we know that this is actually an infinite number of zeros. So it'd be like saying 8.9200000000. No one wants to write that many zeros. So we just know if it's a constant, it's not going to affect my Sig Figs. I'm going to take the Sig Figs from what is my measured value. And here my measured value is that 17.36. So I'm being asked again to solve for volume. Volume is mass over density. I have the mass, I have the density, plug and chug. 17.36 grams over 8.92 grams per centimeter cubed. All right, let's get our calculator. 17.36 divided by 8.92 is going to give me 1.946188. That's plenty of digits. So again, because this is a constant, we're going to ignore the fact that this has 3 Sig Figs, and we're only going to look at our measured value, the 17.36, which has 4. So 1, 2, 3, 4. The 1 does not round the 6, so we lop those off. 1.946. And then what's my unit? Grams and grams cancel. It's going to leave me in centimeters cubed. All right, so that should be enough information for you to solve any of the variety of density problems you might have. Just don't forget, if it seems like you're missing a number, it's probably on your reference packet. So make sure you go and find it, and also make sure you're looking at the appropriate column. You're pulling from this column, this middle one here, density, not from specific heat. Okay, hope that was helpful.